Hello, my name is Steve Bowler, and in this video we're going to be taking a look at logical systems. Specifically within logical systems, we're going to be taking a look at how to use the EM interface option within your Juniper router. If you've already seen the Logical Systems Lab 1, then you know that in Logical Systems Lab 1 we showed you how to use the LT interface option, and in this video we're going to show you how to use the EM interface option to create logical systems. This is Logical Systems Lab number 2. What we're going to do is we're going to take a look at binding logical systems within your Juniper router together to form connections. So as you can see in our diagram, we have router 1, router 2, and router 3. What we're going to do is we're going to simulate all these within one physical Juniper router. If you were with me with the Logical Systems Lab number 1, you saw and you learned that logical systems, we can have some Juniper routers, at the time of this release, some Juniper routers were able to support up to 15 logical systems on one physical router. The logical systems allow you to split up and have different routing processes going on, and you can name them. So we're going to name 3 routing processes: router 1, router 2, and router 3, and then we're able to bind these connections together from one router to another using, in this lab, the EM interface option. In Logical Systems Lab 1 we showed you how to use the LT, our logical tunnel interface, to create these bindings. In this lab we're going to show you how to use the EM interface option to create connections between your logical systems. So let's go ahead and jump right into this lab and let's get this configured. But before we get into the physical router to create the logical systems and link them together using the EM interface option, what we're going to do is I'm going to explain to you the difference between the EM interface option and the logical tunnel option when trying to connect the routers or the logical systems together. With the logical tunnel you had 3 options. You had to give it an IP address. You also had to use the encapsulation command, and then you also had to use the peer unit command. So what we're going to see with the EM interface option when we're trying to bind or connect 2 routers or logical systems together is we don't have as much configuration, but the configuration is different. So we need to explain this so that you have a solid foundation on how this works. And the first key point to see in this diagram is that we have from R1 to R2 we are using EM0 on R1, and on router 2 we are using EM1. They're both using unit 12, our logical interface on this part of the EM0 and EM1 interfaces. You cannot have 2, so we could not link these or bind these together using the same EM interface option. Router 1 is on EM0 and router 2 is on EM1. They're in the same unit and they have the same VLAN ID, but it's very important that we need to separate them into different EM interfaces. EM0 on R1 and EM1 on R2. Same thing between the link between router 1 and router 3. Router 0 is EM0 unit 13 and router 3 is EM1 unit 13. They can be in the same units, but they have to have a different interface. So R1 is using EM0 and R3 is using EM1. So I can't stress that enough for you guys to understand that. VLAN option is one of the key things when we are connecting logical systems together using the EM interface option. So we're going to run through this and I'm going to show you exactly everything that you need to do. So let's go ahead and create let's get into configuration mode. We'll go ahead and create our logical systems first. So we'll do the command set logical systems and then question mark, and then you will see, just like if you watched the first video, we have to name our logical system. So we'll name this R1. So we're going to create router 1 first. So we do set logical systems R1, or you can do the option of edit logical systems R1. And if I hit enter, that brings me to the configuration mode of R1 under the logical systems structure. So from here, I need to create the EM interface on R1 to R2, so I'll do the command set interfaces EM0. If we take a look at our diagram, the diagram shows EM0 unit 12, so we'll go ahead and put that information in. Set interfaces EM0 unit 12, and then we have two options under unit 12 that we have to specify. We have to specify the VLAN ID, and then we also have to put in our IP address. So we'll put in our IP address first, so we'll do set interfaces EM0 unit 12 family inet, and then address. It's going to be, let's go ahead and look at our picture. Our address for this interface between R1 and R2, or the subnet, is going to be 12.12.12.0/24, and then the link between R1 and R3 is the 13 network. So let's go ahead and get that configured. So we'll do set interfaces EM0 unit 12 family inet address 12.12.12.1, again /24. This is router 1, and that is router 1's IP address connecting to router 2. And then the second option we're going to do is the set interfaces EM0 unit 12, and then we're going to, if we did a question mark, you can see that we have an option for the VLAN ID, our virtual LAN identifier value for 802.1q VLAN tag. So in this case, we're going to set our VLAN ID with a tag of 12. So we're going to find out that this has to match up on both sides of this link, and that is why if we looked at our network diagram, router 2's connection to router 1 is also using the VLAN ID 12 option. Okay, so now that we have that configured, if we go to the top of the structure, command structure, and do a show logical systems R1, let's just review what we have created. We have on R1 an EM0 interface. Under unit 12, our logical unit, we put in VLAN ID 12, so VLAN 12, and we gave it an IP address 12.12.12.1/24. This is the link between R1 and R2. So let's go ahead now and create the logical system R2. We can do this from the top of our structure. If we do a set logical systems, then we'll just create it R2, then interface EM, and then remember, we can't put 0, we have to put it in 1. So we'll do set logical systems R2 interfaces EM1, then unit is going to be 12. It can be the same unit on both sides, and then we'll just do the command. I don't know what that, I'm sorry about that, I don't know what I was doing. Unit 12 family inet, and then the address on from router 2's perspective is 12.12.12.2/24. And then our next command is we have to put in the VLAN ID. So we have to tag the VLAN on the the logical interface on EM1 unit 12. So we'll put the command set logical systems R2 interfaces EM1. Again, the unit is 12, and then we have to specify our VLAN ID of 12. So now let's go ahead and try to commit this and see what happens. We'll do a commit check. This is going to allow us to check to see that the configuration that we have entered, or the new commands that we've entered within Junos, passes the verification process and are indeed valid. Let's take a look at our network topology, what we did so far between R1 and R2, we created a EM0 interface on R1 with a logical unit of 12. We put it in VLAN 12, and we assigned it an IP address of 12.12.12.1, and then we created a logical system R2. So right now we have R1 and R2 created in our topology, and then under R2 we created the EM1 logical unit 12 interface. We assigned it VLAN 12 and we gave it the IP address 12.12.12.2/24. So you can see that our check has succeeded. So if we do a commit, actually before I do this, I want to show you guys that in order to get this to work, we have to enable VLAN tagging on the EM interfaces. The way we're going to do this is if we do the command set interfaces EM0 and then follow it up with the VLAN tagging option. Also, we're going to use EM1, so let's go ahead and put that on there too. So again, set interfaces EM1 VLAN tagging. And this is on the physical router itself. We need to specify both of the interfaces EM0 and EM1 to allow VLAN tagging. If we were to look at this, let's go back to our network diagram. So what we need to do is we just need to set this command under the actual physical router that we have. So under the physical router, we have to enable VLAN tagging on the EM interfaces. So I went under EM0 and EM1 and put in the option for VLAN tagging. Very important. If you do not have that, then this will not work. It's very important to do that. Okay, so now that I have that created, there's multiple ways we can look at our logical systems. They all have their own routing table, and so that's really the power of logical systems. It allows us to, we can create up to 15 routers, and then we can pretty much enable any routing protocol that we want between them and look at all the routers' routing tables separately. And we can pretty much create whatever type of interfaces we want on them. So a lot of power with logical systems. That's why they're so important, especially when you are studying for Juniper certifications. And that makes it very good study practice for you to do. Okay, sorry about that. I just had to pause the video. The kids are home. I guess they had a lot of fun today. It's the end of summer, so anyway, enough about that. Sorry if you experienced any delay. So let's go ahead now, and now that we committed that, let's go ahead and do a show route logical systems, our logical system R1. And what we can see is that we have only two routes under this logical system R1. We have the 12 network now. We're seeing the host IP and we're seeing the subnet. So we're seeing the local IP address that's on the logical system R1 itself. And remember, we created that local interface via EM0, again unit 12, our .12, and that's our local interface. And then we also have the directly connected subnet, which is the /24. So let's go ahead and just do a quick ping, see if we can ping from logical system R1's logical interface all the way over to logical system R2's logical interface. So we'll do that by doing the ping logical system. This ping is going to originate from R1, and then we're going to specify the remote IP address, which is the IP address of router 2. So we'll do ping logical system R1 12.12.12.2 to make it, well, we'll go ahead and hit enter. And you can see that we are seeing some replies. So a way I can make it look more, or I can do a wrap ping, and for those of you that are familiar with Cisco and have experience on the Cisco IOS, this makes it look more like a Cisco ping. Oops, sorry. So rapid, and then we'll just do a count, so we can do 1,000 pings. And there you have it. So pretty cool. So far, we're about halfway done with our topology. We have created R1 and R2 logical systems, and we also created the logical interfaces between them using the EM0 Unit 12 on R1 and EM1 Unit 12 on R2. So let's go ahead and get back to R1, and then what we're going to do on R1 is, if we look again at our topology, we're going to create the EM0 Unit 13 and assign it to VLAN 13. So let's go ahead and do that. We'll do the command set logical systems R1 interface EM0. Again, the unit is going to be 13. Again, this is the connection from router 1 to router 3. The family is going to be iNet with the IPv4 address of 13.13.13.1/24. The other thing that we need under the logical unit when we are doing logical systems using EM interfaces is we have to do the command set logical systems R1 interface EM0 Unit 13, and we have to specify from here the VLAN ID. So in this case, the VLAN is 13. Both routers, in this case router 1 and router 3, are going to be associated in VLAN 13. So the next option that we're going to do is we're going to create logical system R3. If we do a show logical systems, right now we have R1 and R2, and we just created the unit 13 on R1, and this is going to be our connection to router 3. If we look at our network topology, R3 is going to have an EM1 interface unit 13, and it's going to be part of unit 13 with the VLAN ID of 13. They have to be in separate EM interfaces in order for the link to work. Because if not, then when you do a commit or a commit check, you're going to see that you're getting an error. Let's go ahead and create logical system R3. And what we're going to do is we're going to assign it the interface EM1. Unit's going to be 13. And then we're going to create it under the family iNet with the IPv4 address of 13.13.13.3/24. We're halfway done with the configuration on R3 to link it to the logical system R1. So the next piece of information that we need is the command set logical systems R3 interfaces EM1. We're going to specify the unit of 13. And this is the very important command when doing logical systems with EM interfaces, is the command VLAN ID, and give it the VLAN ID of 13. So let's go ahead and commit, and we will, let's do this, commit and quit. And just to wrap up what we did, if I go ahead and show you, we just created the EM0 unit 13 on R1, assigned it to VLAN 13. We also put an IP address on the EM0 unit, or the logical unit 13 interface of 13.13.13.1, and then we created the logical system R3. We created the EM1 logical unit 13, and we assigned that logical unit 13 to be under VLAN ID or associated with VLAN 13. So it's very important that both of the routers directly connected are part of the same VLAN. And we also, don't know if I already said this, but we also assigned R3 the IP address of 13.13.13.3. So let's go back, and now to look at the routing table, let's look at router 3's routing table. We'll do a show route logical system R3, and we can see that we have associated with router 3's logical system, we have under the INET 0 routing table the 13 subnet. So now let's go ahead and try to ping from R3 to R1. Again, we're going to do this with the command ping logical system. This is the source of the ping, so we'll do R3. And if we wanted to, we could source it. Let's try to source it this time. So our source is going to be 13.13.13.1, and the destination in this case is going to be 13.13.13. I'm sorry. From router 3's perspective, the source is 13.13.13.3, and the destination is router 1, which is 13.13.13.1. And we'll do a rapid statement, and then we will do a ping count of 100. And as you can see, we are 100% successful. So we have successfully created the connection between R1 and R3. That's it. That's pretty much how you create logical systems using the EM interface option on a Juniper router. So what we showed you is the importance of logical systems. Obviously, you can practice, you can create multiple logical routers within your physical router, and then you can link those routers together using, in this case, the EM0 and EM1 interfaces. And with the power of doing so, we can create BGP connections, OSPF connections, MPLS connections, so IPv6 connections. We can do a lot with the logical systems, and that's why they are very important to learn. With this, what we need to wrap this video up, let's go ahead and I'll show you. If I do a show configuration interfaces EM0, you see that we have the option of VLAN tagging, and also on the show configuration interfaces EM1. It's very important when we're doing our logical systems lab that we have the VLAN tagging on our EM interfaces. So without that, it's not going to work correctly. And also, the other thing we did is under the logical units themselves is we had to assign an IP address. So in this case, from R1 to R3, EM0 under logical unit 13, we had to give it the IP address 13.13.13.1, and then we associated this logical unit with the VLAN ID of 13. So R3, same thing. Under EM1, we created the logical unit 13, and we assigned it the VLAN 13 and gave it the IP address 13.13.13.3. And the last thing that is important with this is, again, between the routers, between the logical systems, we have to specify a different EM interface. From R1's perspective, it's using EM0 to connect to router 3, and from router 3's perspective to connect to router 1, it's using EM1. So thanks for watching this video, and I hope you guys got a lot out of this video. When I first found out about logical systems, I was pretty excited because obviously I like GNS3 and Dynamips, and I like the power that you have by creating or emulating routers, all the different things you can do. So very cool, very exciting stuff. So thanks for watching, and I hope to see you in the next video.